So this is the one that I posted yesterday, and I asked you to turn in. You didn't turn yours in, so make sure you get that submitted to me. I know you did it sitting in class. Just make sure you upload. Okay. So we're going to start with number one is X discrete or continuous random variable. And you guys need to talk to me and make this not as quick as possible, but don't give a lot of, yeah, this is from yesterday. Give a lot of downtime. So we're going to go over this one. And then, like I said, I have another one that we're going to go over. So it is posted in Canvas, and I would suggest that you look at it very, very hard for your test tomorrow. And as soon as this Zoom is over, I will open up your test. So if you wanted to do it now, you can do it now. Okay. All right. So discrete or continuous?
Discrete.
Why is it discrete?
Because it can be many different numbers.
It's single number. There's no like, they're concrete numbers, if that makes sense. So it's not like 1.69483 blah, 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 blah. So they're integers is basically what it is. You can only get 1, 2, 3, 4. You can't get like 1.3, 2.6, anything like that. All right. So then the next one says sketch the probability distribution of X below. So we talked about this, and I'm going to show you how to do it on your calculator one more time. And I know I'm going to get it right this time because I worked really hard to do it. We had, oh, sorry, we got to do our probability distribution first. So we're rolling dice. And we have 1, 2, 3, 4. 1, 2, 3, 4. And we're talking about sums. So what would this first sum be? And then you'd have 3 and 3. And then you'd have 4, 4, 4. You would have your 5s. And then you'd go back. I'm sorry, you'd have your 6s, your 7, and your 8. So then you'd have your X and your P of X. The sums that you can get are 2, 3, 4, 5, 6, 7, and 8. What are your chances of getting a 2? 1 out of a total of 16. So 1 out of 16. You can leave it like that. You don't have to put it as a decimal. What are your chances of getting a 3? 2 out of 16. Yeah. Chances of getting a 4? 3 out of 16. A 5? 4 out of 16. And leave them like that. You don't have to simplify them or anything. Nobody says that you have to do that. 6 is 3 out of 16. 7 is 2 out of 16. And 8 is 1 out of 16. This one didn't ask you to, but if it asks you to describe what you see, and again, I did not, that's where you're going to talk about shape, center, spread, outliers, anything like that. So shape, center, and spread is what you're looking at. Here's what you do. 2, 3, hopefully I can clarify exactly how to make these on your calculator. 4, 5, 6, 7, 8. Your probability, 1 over 16, 2 over 16, 3 over 16, 4 over 16, 3 over 16. Tell me if I put something in wrong. 2 over 16, 1 over 16. All right, so to be able to see this, if it asks you to describe, because I think there's another one in a minute that asks you to describe what you see. I didn't on this one because you had that one. You're going to change your window, and your X values are from 2 to 8. So that was our top line, 2 to 8. And they go up by 1. So 2, 3, 4, 5, 6, 7, 8. Your Y minimum is going to be 0, and it goes up to 4/16 is what? What's 4/16? Reduce it. No, reduce it. 1/4 or 0.25, right? I did 0.5, and then I went by 1/16. Why did I go by 1/16? Because that's what they all are. Okay, if you just wanted to do 0.25, that's fine. I just like to go a little bit above. Okay, so then I'm going to graph it and you can see your distribution. So what do you see? It's unimodal. It is roughly symmetrical because it goes up and comes back down. It might be a little bit skewed, but this looks pretty symmetric. Okay. If you look at your data right here, 1, 2, 3, 4, 5, 6. Now, what can come from that is if I'll take my max up to 9 and graph it, it'll help that out. So what I would suggest is always go 1 above, and that's what I did on the other one as well. I just wanted to show you this one. So if you go 1 above, it'll make it look a little nicer because 0 is like 1 or 2 below. Okay, so try to make it where it fits perfect in there. All right. What's your center? Where's your center on your probability chart? Look at it again. 5 is going to be your peak, right? 5, so approximately 5. And since this is normal, would it be your mean or would it be your median? It's kind of tricky. It's both, but if we're doing normal, we should describe it as the mean. Okay, so symmetric deals with mean and standard deviation. If we're skewed, median, and range or IQR. All right, and then what's your range on this one? 2 to 8. That's it. Okay, so that's what they're trying to get you to describe. If somebody rolled the dice 10 times and got a sum less than 3 each time, so this is the only one that's a sum less than 3, would you be surprised? There is no work to this. It's just a question.
Yes.
Why?
Because there's only one that has a sum less than 3.
There is a low probability of rolling a sum less than 3. If they asked you to find it, then you would do the work, but they're not asking you to. So that's it. So that's the first page right there. Probability distribution. Remember that probability distribution should add to what? 1. Okay, make sure you remember that. So this one says sketch the probability distribution. So I'm going to go back to my calculator and I'm going to edit 0, 1, 2, 3, 4. Sorry. 1, 2, 3, 4. 0.155, 0.195. If y'all want to put these numbers, you don't have to put them in your calculator, but if you want to know what your scales were, that would help you look, then that would be fine as well. So on this one, I put in the values. I'm going to change my window. I'm going to do my window 0 to 5. You could do it -1 to 5. It doesn't matter. I just, like I said, like to go like 1 above. So 0 to 5 would be what it is. And your scale is by 1. Our minimum can be 0. Our maximum, if we look at our numbers, 0.24 is the biggest one. So I went to 0.3. And then I did my scale by 0.05. I just picked something random. Okay. Then when I graph it, I can see it. What does it look like? Again, if you want to change your window a little bit to go 1 above, 1 below, it might even it out a little bit. It doesn't really matter. What
Miss Jones, are you graphing this in like the stat window? It's not work. I don't know. It like sweet. It's fine. I'll figure it out later.
Okay, don't stress out about it. If you want me to, we'll zoom and I can get you to share your screen or whatever. We'll figure it out. All right, so I'm gonna take this back to 0 because I don't like the way it looks. Here we go. What is this one? Unimodal. Roughly symmetric.
Is the median 2?
Looks like it, right? 0, 1, 2. Median or the mean is going to be 2. What else?
And the stretch, I guess.
The range?
Yeah, is 0 to 4.
0 to 4. Good. All right, so there's your sketch. You guys can just pop that on there. Remember, if you're doing this, you can hit trace and it'll tell you what's in there. So this is 1 and it's 0.155, just like we did before. 2, sorry, this is 0. This is 1 at 0.195, which is exactly what these are. So you can just rough sketch it. And I know this is real ugly. 1, 0, 1, 2, 3, 4. and then put your values up here like they did. So like this, and then make sure that you label them, okay? So this would be probability, and this would be goals. It doesn't have to be anything fancy, okay? Nothing fancy. All right, calculate the mean and standard deviation of Y and interpret them in context of the situation. How do we use this to calculate mean and standard deviation? What's the easiest way to do it?
You plug them into L1 and L2.
We already have them in L1, L2.
Then you go to this guy, right?
Mm-hmm.
Yeah, and then calculate one more step.
Mm-hmm. Make sure frequency list is on L2, and then calculate. What's our mean?
2.076.
Standard deviation.
1.318.
Good. All right, so in context of the problem, but remember with the probability, you have to add that last little part. This was in the beginning. So our beginning, this would be perfect, like chapter 1, 2, 3, whatever it is. But here, on average, the team scores 2.076 goals per game after playing many games. So remember that. Probability is an overall or a long run average.
Do you have to put randomly selected in this one?
You can, it's not anything. We're not selecting anything on this one, so I wouldn't. All right, so what about your standard deviation? The number of goals would what? Would typically differ from the mean by about 1.318 goals. That's it. Okay, so the next one, the weights of toddler boys follow an approximately normal distribution with a mean of 34 pounds and a standard deviation of 3.5 pounds. Suppose you randomly choose one toddler boy and record his weight. What is the probability that the randomly selected boy weighs less than 31 pounds? So we need to write this, the probability that this boy weighs less than 31 pounds. How do we find this in our calculator? Normal CDF. Remember, define everything. What's your lower?
0.
It doesn't matter on this one. I told Mackenzie yesterday 0 because you can't really get below 0 on your weight. But if you put a randomly like super low number like negative 10,000 like we've been taught, that's perfectly fine as well. It's not going to change it much. So just tell me how much yours differs, okay, from what we get. It's not going to be much at all. What's your upper?
31.
Mean? And then your standard deviation. And then when you put in 0, you get 0.9157. So did you put a randomly low number?
Yes.
See what I'm saying? So it doesn't make much of a difference to put in that negative 10,000. But what you do by doing this right here is if this number is off at all, and they see that you change this from 0 to negative 10, they're going to take that. Okay, so that's what that does, is helps them see, okay, you did the process right. All right. So that is all of 6.1. That's what you learned in 6.1. So then we move to 6.2. A carnival game involves tossing a ball into numbered baskets with the goal of having your ball land in a high numbered basket. The probability of distribution of X equals the value of the basket on a randomly selected toss is right here. The expected value, remember, expected value is the same thing as the mean. So don't forget that, is 1.1 and its standard deviation is 0.0943. Suppose it costs $2 to play and you earn $1.50 for each point earned on your toss. That is, if you land in a basket labeled 2, you earn $3. So define Y to the amount of profit you make on a randomly selected toss. Describe the shape, center, and spread of the probability distribution Y in the context of the situation. So what are you doing? What is my formula for Y? It costs you $2 to play. So what's that mean? You minus 2. But you can earn, which means plus, $1.50 for each throw. All right. We're going to go ahead and find our mean and standard deviation, and then we're going to talk about the probability distribution, okay? So how do we find our mean? Sorry, I don't know what I was doing. But what's your X? If we're looking for the mean Y, remember this is going to be the mean X. Which gives you negative 0.35. So remember when we're defining the shape, center, and spread, the shape we're going to do from graphing it. The center, right here, we're finding the mean. There's your center. The spread, how are we going to find it? How do we find it? So our formula looks like this, but when we do standard deviation, remember we don't add or subtract because that doesn't change it. So we're actually just going to do 150 times the standard deviation of X, which is perfect. You did absolutely correct. Our standard deviation from the beginning was 0.0943, which gives us a standard deviation of 0.14145. All right, so if I graph this is the only time I have to use my calculator. We have 0, 1, 2, 3, 0.3, 0.4, 0.2, and 0.1. And why can I graph these and not have to worry about any of the 150 or the 2 or anything like that? Why can't I just go based off the data that I have?
Because nothing changes the shape.
Absolutely nothing changes the shape. You got that? Nothing changes the shape. So it doesn't matter. So I changed this. Oh, sorry. My X min is 0. My X max is 4. I went 1 above. My X scale should be 1. My Y min is 0. My Y max, I'm going to put as 0.5 and go by 0.1. Let's see what happens. So you can see, what is this one? What's the shape? So your shape is skewed right. Your center, and it says describe in the context of the situation. Perfect. What'd you put for the center? So on average, a player will lose 35 cents. And I'm going to put this saying right now because you haven't seen that yet. And we're going to say in the long run or after many, many games. Something like that that tells you but it's been a while because again, probability is the long run probability. It's not short term, it's long term. All right, and then your spread is obviously your standard deviation in context of the problem. What were we looking for? What was this equation about? What was y? The profit. So when you talk about the spread, the profit will typically vary from the mean by about 14 cents. Everybody good? All right, next one. If each student checks, y'all read all that. If each student checks one after the other, what are the mean and standard deviation of the total time necessary for these 4 students to check their homework on a randomly chosen day? So we're looking for the mean total. So remember when we total, that means we're going to add everything up. So we're going to add all their means. So we're going to add the mean of Alan, Barb, Corey, and Doug to get a total of 4.5. It doesn't ask you to interpret or anything like that. So you're done with the mean. But then it asks you about the standard deviation. So remember when we're totaling it, what do we need to do to find the standard deviation? When we're totaling, what do we need to do? What are you looking for? Not the standard deviation, but close. The variance, yeah, the variance. So the way we find that is the standard deviation squared of each one. And then take the square root, and you can write it just like that, and that's fine. And you should have came up with 1.1402. Okay, so again, when we're totaling, we're adding or subtracting, you need to make sure that you find the variance and then take the square root. Okay, you can't just add the standard deviations. Suppose Alan and Doug like to race to see who can check their homework faster. What are the mean and standard deviations for the difference between their times? So they told you Doug minus Alan. Interpret these values in context situation. So this one you do have to interpret. So we're looking for the mean of Doug, or the mean of difference, which is Doug minus Alan. What was Doug's mean? 1.0. Alan's mean was? Which gives you a negative 0.4. So what does that mean? Be careful because you're talking about time. So think about swimming.
All right, he's slower.
If he has a negative 0.4, what does that mean? He's faster. Doug is faster than Alan by 0.4 minutes on average. What about the standard deviation of the difference? How do I do it? You have to find the variance first. And then what do I do? How do I do it? Why'd you plus? You always add when you're talking about variance or standard deviation. And then we take the square root. So always add, if you need to put that, always add. This will give you 0.71. So this means the difference between Doug and Alan's times will vary by about 0.71 minutes. And when I finish this sheet, I'm going to go ahead and go out. I'm going to make 2 separate recordings. So I'm going to make this one. So I'm going to go out, make it, and then I'm going to come back in and do the next one. You want to leave, you can, but I would suggest that you come back in for the next one. All right. So 2 more questions. All right. Molesky and Liberty are avid video game golfers, blah, 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 blah. Find the mean and standard deviation of the difference of their times. And it told you Molesky minus Liberty, assume that their times are independent. Remember, if they're independent, then we can go ahead and find the standard deviation. Okay. So the mean of the difference. So what are their means? Molesky minus Liberty. 110 minus 100, which gives you 10. It doesn't ask you to interpret, so we're done with that part. Now we need to find their standard deviation. So what do I have to do first?
On the variance.
The variance. And then we always do what? Add. So Molesky's was 10, so we're going to square that. And we're going to add. Liberty's was 8 squared. And then we'll take the square root and get 12.806. All right, so be careful on this one because you're dealing with time again. Find the probability that Mr. Molesky will finish his game before Mr. Liberty on any given day. So remember, lower times equal faster. So don't forget that. So we're looking for the probability that the difference is less than 0. That's a D. I know it looks like a 0. I'll fix it. Why do we want the difference less than 0? And not greater than 0? We don't want it greater than 0. Same thing as last time. We just talked about that negative time makes the person faster. Okay, so we want a negative time to know that they're faster on the difference. So how do we find this in our calculator? What do we do? We need our lower, our upper, our mean, and we're talking about the mean difference and the standard deviation of the difference. We've already calculated these. That's from part 1. So what would your lower be if we want less than 0? Just a really low number. What about our upper? What's the highest we can get? 0. Our mean from before was 10 and our standard deviation was 12.806. Rounding, I rounded this number, so this number may be rounded as well. You get approximately 0.2175. And then you need to say it. There is a 22% chance of Mr. M finishing before Mr. Liberty on any given day. And I left out like all the game stuff. That's fine. Don't stress out. On the AP exam, don't leave it out. On my test, it's fine. All right. I'm gonna give you a chance to get this down, and then we're gonna go out and come back in, and I'm gonna look at the other review. Anybody on Zoom need more time on this? We're good. All right.